Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and we are here today to talk about proportionality. This is EOG Bowling Review number 4. This video will take you all the way back to Unit 5, when we talked about proportions and what they are, ways to determine it, and two kinds of practice problems you might see on the EOG and on your homework. Okay, for two quantities to have a proportional relationship, that means that they have two equal ratios. The word proportion means two equal ratios. That means they have the same rate of change. They change at the same rate. Okay? Way back in Unit 5, we talked about 4 different ways to determine proportionality. The first way was if we had equal ratios. So if we have equal ratios, that would be like 1/2 and 6/12. We can tell if they are equal by either cross-multiplying them or seeing if they have the same rate horizontally or vertically between them. Okay, in this example, 1 times 6 is 6 and 2 times 6 is 12. So that tells us that 1/2 and 6/12 are proportional. Okay, the EOG and the homework might also ask you to look at a table. If I have the same rate throughout the whole table, it means that the table is proportional. For this example, if the X column is 1, 2, and 5, and the Y column is 3, 6, and 15, I can take X and multiply it by 3 to get each Y. 1 times 3 is 3, 2 times 3 is 6, and 5 times 3 is 15. That tells me that that table has a proportional relationship because it has the same rate all the way through the whole table. Okay. The only way a graph can be proportional is if it's a straight line that passes through the origin. The origin is the point 0, 0, right here on that graph. Okay. If the line passes through the origin and it's a straight line, that means that is a proportional relationship. That's what we talked about in Unit 5. We can also look at an equation to see proportionality, where y equals k times x. K there represents the constant of proportionality. For example, two different equations like 1/3 x or y equals 6x. Those are both proportional equations because they have one coefficient and just one coefficient in front of the variable. That k is the constant of proportionality right there at 1/3 or right there at 6. Okay? Those are the 4 different ways to determine proportionality. Again, proportions are two equal ratios, and we're going to see lots of problems about rate and proportions here in this practice session. All right. In number 1, it says the table shows how much a store charges for certain numbers of pencils. Okay. The first thing I want to know is I want to know which equation could be used to calculate the cost, C, of any pencils, P. So I want to calculate the cost per pencil there. I want to know how much one pencil costs, the cost per pencil. In order to do that, I can look at this chart and I can actually pick any row in this chart. I'm going to pick this one right here. And I'm going to see how much one pencil would cost if it was 72 cents for 4 of them. If you take your paper and you try to put 4 into 72, you should determine eventually that is 18 cents per pencil. Because I got 18 cents when I divided 1, I could take another one and try it if I wanted to. If I take 1.26 and divide it by 7, I still get 0.18. And if I take 2.16 and divide it by 12, I still get 0.18. That tells me that A, that the ratio is proportional, but it also tells me that the only answer choice that makes any sense is B. That's the one with 18 cents in it. This says that the cost is worth 18 cents per pencil there on answer choice B. And that's the one that I would choose there on that first example problem. Okay. We saw a lot of problems back in Unit 5, like number 3. This one says that Chad built a scale model of a statue. If it's drawn to scale, that means it is proportional to the real size. Okay. So he built that scale model 7 inches tall to represent an actual height of 15 feet. So the model is 7 inches tall. That represents the actual height of 15 feet. Which equation below represents the relationship between the actual height, A, in feet, and the height of the model, M, in inches. Okay, so M represents the height of the model. A represents the actual height. I'm going to look at answer choices A, B, C, and D. I'm going to plug numbers into those equations to check. So if the model was 7 inches tall, that's what M is, and A should be worth 15 feet. So for answer choice A, that's saying A equals 7/15 M. So I plugged in 15 for A right here, and I plugged in 7 for M right here. If you take 7/15 and multiply it by 7, you get 49/15. And that is not the same thing as 15. In fact, 49 divided by 15 is 0.0666666667, which is not what I'm looking for. Okay? But that's not an answer choice, which is great. It's great news. If I look at answer choice B, that's saying that 7, if I plug in for A, is worth 7/15 15. This one might work, y'all. I'm feeling it. If I take 7/15 and multiply by 15 over 1, I get 7. 7 times 15 is 105, and 15 times 1 is 15. 105 divided by 15 is 7. If 7 equals 7, that means that's the right answer, because that's the one that represents the scale model in that equation. Okay? These two answer choices right here, they're obviously wrong, because I don't see 0.75 anywhere in this problem. Answer choice B is the right one to choose. Okay? So I've gone through 2 practice problems there for you. Okay, you're going to look at Mike. You're going to look at this one about distance on a map and actual distance. Talking about Dante, blood in a person's body, lines in a grid, number of tickets to a show, and the movie theater. Okay, good luck working through those problems. I really hope that you work hard and try your best to understand those questions and what they're asked of you. Okay, remember, you can only get so far in life if you don't put forth effort. You want to put forth effort to be successful at this. All right, make it a great day or not. The choice is yours. Thank you.